It's doing electrical and mechanical.
No,
The stuff that he threw out, or the calculations.
Oh, because Chris knows
threw
I
out there
put
with all the
had
group
a problem with
symbols.
one of the
That's
LEDs,
all.
so I tried to
That
take
was
it
all
out, which is
controls
really hard.
and controls.
Right,
They
really hard.
and
I
ended up
recognized
screwing
it
up the leads.
from
I
me
actually
being
ripped
on the
the
mechanical
leads in the
engineer.
process of
And I
taking it
took
out. But I
controls
figured out that I
courses.
could just jumper the
And
power.
I know that
power
electrical
ground
guys
across
typically,
the-
you
the
typically
messed
don't
up
find a
lead.
lot of controls courses that are geared towards mechanical engineers. At least I didn't know when I was going through school. It was the electrical engineers went through controls courses. But it definitely is. It's something that's good to learn, I would think. And I don't know. You should see if you can't get into that as well. At least be able to take classes that allow you to take that stuff. Because
I think some of the courses I'll end up taking as options include control theory, which is very applicable to robotics. So it's my plan of trying to pick as many of those ones as possible.
and it's good though, because those controls and classes are typically master's level courses.
Right.
But they allow you to take them. You just don't have to. Because you're in a bachelor's program,
No, I know.
you get relief from a couple of requirements, like a couple of papers. But it's the same.
The mailbox,
You're in there
mailbox, yes.
typically with
Mailbox
master's
robot
students.
is coming.
And,
So in the next couple of weeks.
and I mean, even though I never got to use it, I can see how. I'm glad that's your house. If I never even wanted to get back into it, I'm not even close to a lot of other people. I wanted an easy way to take a solid modeling class. So, solid modeling, you can go and get a course anywhere. Solid modeling and pay a few $100, right? Controls theory, you can't do that.
Okay.
Yeah, controls is everything. Robotics, propulsion, space. Everything. I mean, it's in everything.
They live in LA. You think they could fly out? Drive down?
All my books and relearn it.
Is it okay if I record it, Chris?
Yes. First thing you did was take a plane over back to the lake. Fly to Monday. Fly back to San Francisco.
Fly out of here. That kind of connection.
Yeah. Well, it connections in LA. Why couldn't they just catch it? Well, when you fly into San Francisco and catch another 737. And I did pick them up at 45:30. But I did get to borrow their car for 2 weeks, so it's sitting in front of my house with my other 6 cars. I parked my neighbor's.
You did 5 characters. Oh, yeah.
Okay, hello everyone. My name is Chris Carter. I am the president of Civic Natilus, and these are a few of my least favorite things people say to me.
God, focus.
Focus.
I said in my eyes.
Oh. Okay,
Yeah.
better?
Yeah.
Okay, I am an odd bird. I don't do things the way everybody else does. So I'm asking everybody to refrain from these. In my group, it's the first thing I show. Dr. George can attest to you that I do things differently than anybody else. Again, my name is Chris Carter. I'm president of Pacific Natilus, which is a student-run, started out as a student-run not-for-profit that we worked at community colleges, giving community college students access to cutting-edge research that was not available to them. Now we have started the CubeSat Pacific Natilus, and that's one of our vehicles that prototypes that we built. And so I'm going to walk you through how we came to the ideas of the things that we do. If you look at all these vehicles in the Autonomous Unmanned Systems International RoboSub competition, one thing you will notice, they all look exactly the same. These are international teams from around the world, schools like MIT, Cornell, Duke, schools from Canada, India, Korea, Japan, you name it. And their vehicles all look the same. The EVSI is a professional industry organization made up of industry and government officials. They created this organization to promote students to create autonomous systems. They do underwater, surface water, ground, and 2 aerial competitions. It's an international competition organization. Have competitors are MIT, Cornell, Duke, Florida State. MIT, Cornell, and Florida State have been in first place the last like 10 years, 9 years, one of those 3. When we entered the competition, our first year, we placed 17th out of 21 against universities. We were a community college team. And then our second year, we placed 9th out of 27 teams. So in 2 years, we made it to the top 10. So we started out in, originally when we built this competition, we had our own methodology. We broke it up into things like hull design, power systems, electrical systems, propulsion systems, sensors, control sensors, and software. Little did we know, little did I know, this is pretty much systems engineering, a very light version of systems engineering. So we're hoping to carry on this type of breakdown and employ some other things. So these are some of our propulsion concepts that we came up with. Control collar that allow the screw to lock in place for our wing design and our vector thrust. So we had an idea of taking water, propelling it through vectors in order to propel our vehicle forward. We had a magnetic pump, 2 one-way valves, electricity turning on and off, a magnet that would push water through it, including our idea of an Archimedes screw from Natilus. Some of the things that we came up with in our brainstorming designs for different hulls. Basically a flying wing, Star Wars, a Thule, we got that out, and we had considered it because the vehicle could be 6 feet by 3 feet by 3 feet. Until one professor realized we'd have to fill it 90% with water in order to get it submerged. And then basically something very similar to a dirigible. One thing interesting about our hull designs is people told us that we were crazy or stupid or our ideas would not work. That was in 2005. Anything look familiar about this vehicle from 2013? It was one of our designs in 2005 that someone actually employed in a vehicle competition. So I like crazy ideas because sometimes they do them, okay? They do work. And one thing I want to say is, and someone told me about this and I love it, Alexander Graham Bell said, I found out 100 ways, I never fail, I found out 100 ways of how not to make a light bulb. Edison? Okay, Edison, sorry. Edison. The colored school, though. I got the wrong person. So this is one of our original ideas, is we took a hovercraft because it behaves very similar to what happens in water. Learning to control and understand the movement of a hovercraft was very key to our success and how our vehicle worked underwater. So that was our original Model A full-size prototype concept. We actually built it out of wood. So we took what I thought was a good vehicle design. It takes advantage of what we call laminar flow, very stable. It can eliminate 2 degrees of freedom. You don't have to worry about roll, just pitch and yaw. And how you navigate is you do planar navigation. You're here, you want to be here. Instead of doing this, you do this plane. You get to this plane, and you get in this plane. It's a lot more accurate than 3-dimensional navigation. And you almost get it 100% of the time. Nothing's ever 100%, pretty close when you use planar navigation. Second iteration of our vehicle was this. So we took what we learned from the original design, and we built this prototype. This actually uses what I call an inverted pendulum. It's heavy on the top, light on the bottom. It's much more stable. One of the things we were able to do is take it to Balboa Park, run it to the middle of the fountain, and it rode that flow right through the center of the most turbulent part of the fountain without upsetting. Then we had our Model B design. The guy, a very interesting story about this vehicle, this design. I needed someone who had some artistic ability. I do not. He was a graphic artist major from UCSD. He sat down, him and I, and we put down in graphic. These are all pictures. He put them together, pasted them together, did his magic to create this vehicle that we used to get money to get people to sponsor us before we actually built the vehicle. Take a look at what we actually built. Pretty close to what we actually built. One of the things we learned was that these were too low. They have to be center of gravity. We moved these down lower, as you can see, batteries. Everything that we designed, because we did a really good idea of designing the vehicle before we actually started putting the parts together. Researched the parts, did what we wanted to do, and this is the actual vehicle on the platform at the competition. Something kind of cool about this vehicle. So people knew that we were from a community college. People knew that this was our first time doing this. We were told that this vehicle was too small and too light to be competitive. It was 17 inches tall, 6 inches in diameter. We had to add 10 pounds of weight to it to get it to be submergible. It has to be 0.05% positive point. So if it died, it has to slowly be able to rise. We made it through the validation gate, our first time out, and we didn't leak. So those are two things that other teams have been doing this for a long time, and they still leak. I know teams that have been doing this 10 years. Our mantra is we don't leak so much they wanted to call us the no leaks. But what was amazing about this team, about this victory for us, is that when we made it through, I don't know if you were there, the entire arena erupted in cheers because first time team through the gate, never leaked. You wasn't there? So what we used, which is totally different again, was a basic stamp. Probably don't remember those, the Board of Education boards. It only uses 4 words. That's it. Yeah, we have 5 of them. So if we go back to that vehicle picture, there are 5 boards. You can see them. And I think we had, one up there, and I think we had one more somewhere. But there are 4 or 5 boards that we use. 4 words each. Everybody else was either using small board computers running Debian Linux or Windows. Again, they told us we never create a vehicle using a microcontroller. Not only did we place 17th with this vehicle using a microcontroller, the following year we used a TI microcontroller and we placed 9th. We were able to make it dead center through the validation gate every single time without fail. There are teams that have been doing this competition a long time, but they couldn't even make it in water, let alone through the validation gate. One team spent $400,000, and let me say that again. They spent $400,000 of a DARPA grant, and they didn't make it in the water. So, I have some more crazy ideas. I want to use a Raspberry Pi and combine it with some Arduinos to do this. Now, after I came up with this slide, I met with a gentleman Dr. David Wayne, who works at Spacewar, who's coming on board as one of our advisors, suggested we look at the BeagleBone Black, because apparently someone else had the idea. They just thought of doing it with the BeagleBone Black as opposed to Arduino, and there may be stuff that we can borrow, use, reuse, or learn from. I don't know if any of you have seen the Raspberry Pi 2, but it blows the Raspberry Pi 1 away. It's a gig of RAM, it's 900 and something megahertz, it's about 10 times faster than the Raspberry Pi, and it has 4 USB ports as opposed to 2. They did away with the RCA, but they kept the digital and the audio out. It's actually, I have one. It's actually pretty cool. I do like it. So that's some of the ideas that I'm thinking about. So that brings us to the CubeSat. Again, I'm going to have some strange ideas because what we're about to do is something that's not currently been done. And NASA's asking these things to be done because no one has done it. Most of the time, people are using a 1U CubeSat. This is printed in a 3D printer. This is what I call my field case touch test. These are what people use to build the satellites. And they launch from a Peapod, and then they circumnavigate the Earth until they fall back to the Earth. NASA's not asking for that. They're asking for a 6U unit that will fly from their launch, the Space Launch System. I don't know if anybody had a chance to go see the Rubin H. Fleet Center's space. Go see it. It's about the SLS, the Supplemental Launch System, and NASA and Orion. It was really a great look into what we can't see they got behind the scenes because the SLS is not available for the public yet. But this guy has got behind the scenes at the SLS and the Orion, which is the next iteration of a reusable spacecraft to replace the stations. It was really interesting. And we want to get on that SLS in 2018 for its first launch. That's the goal of that's what we want to do, is to launch our CubeSat on NASA's supplemental launch system.
You said a 6U. That's a 3U.
This
so
is
it's
a
double
1U.
that size.
This
Oh,
is
so
one.
it's
6 of these.
So it's 2 by 3.
Mm-hmm. And NASA's wanting that. Most people do either a 1U, 2U, maybe even a 3U. This is the first time. A 6U is going to be deployed, but it has to leave the launch system, circumnavigate the moon, maintain a height no less than 6 kilometers above the moon. Don't know if you know this, but the moon, according to the United States government, is a national treasure, and you are not allowed to crash your satellite on it, so you have to have a safe deploy algorithm inside your CubeSat to safely crash it into the moon, because you could go to jail for destroying a national treasure. Yes, you hit something that's up there from the previous.
Hopefully there is a way.
Well, like I said, it's the law, which I found really funny. But then I did some research that the moon is considered by the United States a national treasure. Yes.
So why are they asking for 6U?
Well, it's really hard to put thrusters in here and make it go from the Earth to the moon.
Well, it's already going to be launched on a moon.
You
orbit
have to
from
be
Earth,
able to. It'll be launched at about 4 kilometers per hour. I think it's 4 kilometers per hour. But you have to do your path determination. You got to get through asteroids. You have to get through your trajectory. You have to actually get to the moon. And then once you get to the moon, which is quite a distance, and it's going to be really hard to propel this to the moon without some kind of thrusters, which is why they have a 6U. And then you have to send back 100% error-free data. So that's the two challenges, is to actually get from wherever they launch you to the moon, maintain in verifiable orbit, and then send back data. And I think you have like 30 days to complete the entire mission.
You have to orbit the moon.
Yes.
Okay, so you're already sent on a
You're sending
trajectory
through-
that will reach there, and you have to launch.
off-
You have to do an orbital.
There are at least 4 or 5 satellites that are eligible at the final competition. You're going to be launched at whatever order yours is. So you're not going to be on a trajectory directly to the moon. You're going to be whatever trajectory as the SLS goes, you're going to be launched. And then the next one's launched. And then the next one's launched. So they're not going to put you in a perfect apogee to get to the moon. They're not. That's not their primary mission. Their mission is to get you into space. Once you're in space, your mission is to get to the moon. So they're not going to line you up and send you that way and shoot you off. They're going to be deploying whatever else they're deploying on this multi-billion-dollar supplemental launch system, and they're going to shoot you out as they go by, along with all the other stuff that they're shooting out.
It's going to be from the lower LEO, like from the lower orbit.
Well, see, they haven't got that part where they're going to send you from LEO, MEO, or high orbit. They don't know. They haven't mentioned that yet.
Okay.
Again, they have other things that they're setting up. You're just one of 4 CubeSat missions of the many missions that are already on there, because they also send up 1U CubeSats at universities, so they'll be launched also. They have another competition that allows universities access to the Space Launch System. So their CubeSats will be launched, and they'll probably be launched in LEO.
Yeah, definitely.
But that doesn't mean we don't know where we'll be launched, and I think that's part of what they'll tell you closer to the mission, because they're going to have all these other missions that they have to plan for. So you're going to have to figure out your own trajectory and how to get to the moon, and then have enough power to circumnavigate the moon. That's competition 2. They call that the Lunar Derby. The first 4 competition, which they consider one, is called the ground competitions, and they're basically design competitions. The most exciting one to me is what they call the Far Earth mission. You have to travel a verifiable minimum of 4 million kilometers. Verifiable 4 million kilometers. And again, send back error-free data. And you have 1 year. So from the date of the launch, you have 1 year. So if you can purchase your own flight into outer space, you have 1 year. If you launch with NASA, you have 1 year. If you launch after NASA, you still only have that 1 year based on when NASA launched their SLS supplemental launches. And then they have what they call an endurance, $250,000 for the satellite that lasts the longest. So it can go past the 1 year, but the last one out there sending data is eligible for an additional $250,000. It's a total of $5 million in prize money. So what we're using is we're using the NASA's Systems Engineering Handbook. So I figure if we're going to build something that NASA wants to put on a multi-billion-dollar supplemental launch system, they're not going to let us anywhere near it unless we follow their rules. And if they can say, this is our checklist, you've done it just like we do it, as opposed to you did it your own way, and how do I know what this data is? How do I know it's correct? What is your source for this data? What is your verification for this data? So we're going to use the NASA Systems Engineering Handbook. And this book is a systems view of spacecraft. So there's a lot of stuff out there that we can use to planning mission requirements, launch vehicles, space systems, the ground segment. So there's a lot of information out there that we can take advantage of. One of the things I'm kind of excited about, there are 3 of these. This is a pocket cube. So this is a pico satellite. It's about half the size of this. And these people have a pico satellite kit. It's either a 2U. I'm hoping to get a 3U. So they call it 3P because it's much smaller than this. It comes with a development board, a mini SATCOM radio, an onboard computer, and it's not shown, but there's a development board just for the satellite communications.
Half in one dimension,
It's not quite half.
but in one dimension.
No. It's 5 by 6 by 7 centimeters. So it's just, it's not. It must be you. Because I don't recognize that sound. So it's not quite half. I think it's 104 centimeters long, whereas a pico satellite is 30. It's slightly larger than a pico satellite, CubeSat. ISAT, it's a nano satellite also, but it's a complete 1U unit with a whole bunch of things, including batteries, radios. It has basic software. It's a 1U package, and it's complete. And it's so there's 2. There's a EM and an FM engineering model and a flight model. And the flight model, I made a mistake when I was doing some preliminary costing 4 weeks ago when I first started doing this. I was pricing the flight models, the engineering models, because they were cheaper, but they're not flight qualified. So you got to get the flight model. And so I've been repricing some things. The one I'm most excited about, it's probably the most expensive, is the CubeSat training kit. It is a 3U CubeSat. And it has its own ground station. So it has a separate ground station already built in. It has radio. I think it has everything but, solar panels, which is going to be a very key component of what we do, learning how to make sure we have enough power. But that's an extremely exciting training kit. I've actually been in contact with Pico Satellite, and I've been in contact with the people who do this, not the CubeSat shop that sells it, but the actual people that make it. The only problem is they're phasing this one out, which is about $10,000 for a new model that they sent me an email that's $54,000.
Still a
So-
3U.
Huh?
Still a 3U.
Mm-hmm. But it's, if I believe it is a FCAM flight model. But everything you need to learn, including ground support, is included in this 3U platform. It's an amazing tool if we can get it. So there's a couple things that I'm very interested in doing. One is called the CubeSat Cookbook. It has a lot of stuff in it that we can actually utilize to get us prepared. And we're fortunate that Dr. George met or somehow got in touch with Dr. Wayne, who builds CubeSats for spacework. So he's going to be an invaluable tool. And he's actually going to try to be able to do engineering testing at spacework. So he's got to get permission, but he liked our original group that he met on Saturday, and hopefully he can help us realize some of the stuff we're going to and give us access to stuff that we don't have access to. This guy, Sandy Artunes, is a astrophysicist as well as a blogger and writer. So he decided to build a CubeSat. And then decided to write 3 books. And I've gone through a couple of these books, and they're very interesting. The platform, the instrumentation, and how to make your satellite space-worthy. One of the things he did was he's able to make a vacuum chamber out of a pressure cooker. He was able to make a shake table out of an orbital sander. So he's actually come up with some really interesting ways to test your satellite for space worthiness. And I thought it was interesting. So, why I want to do this? The best way to understand space is learn how to explore it. The best way to learn engineering is to design a mission. The best way to emphasize mathematical rigor is to apply math to solve interesting problems. The current rapid advancements in picosatellite access, and he says pico, but that's including nano as well as CubeSats, is changing the way things are done. And so the old model is, can it be built, to what can I get that's interesting that's worth building? And that's from the Do-It-Yourself Instruments, Sandy Antunes, and I liked those quotes, so I wanted to share them with you. Okay, so NASA Systems Engineering. Actually, all of us have this book, and we're actually reading it. We're actually discussing chapter 2 right now. There is a methodology for using system engineering that I found very useful, in that teaching it to the young people and employing it in our CubeSat development will get us that much closer to consideration with NASA for deployment. I don't think they'll let us near their satellite unless they can verify what we do, why we do it, and how we do it. And so this is the systems engineering diagram that they use. Where you have your systems engineering and your project control. We hopefully implement that structure, and right now we're in the process of developing that structure, and then it's going to be based on who participates. We actually just got an email from a gentleman in the Caltech grad who wants to be our RF engineer. So he did email me back. Yes, thank goodness, because we don't know anything about RF. So he's interested in working with our radio. And then again, some other engineering processes that we're hoping to take advantage of. We may not copy it exactly, but we're hoping to utilize the stuff because according to Dr. Wayne, who works for the government likes when you follow their procedures. Okay, so Dr. George is actually going to talk to you quickly about air-free communications and the math. He's a theoretical physicist as well as our math genius, and he's going to talk to us about some of the stuff he's been doing on air-free communications.
Well, what I've been thinking of, actually air-free communication is a subject that is pretty well known, so what you're dealing with here is not something that people aren't aware of. It comes from information theory, and information theory has been very well developed. And so if you go to Claude Shannon's works, you can see that this kind of thing has been considered before. What you're dealing with this situation is that because of the weak signals that you're going to be sending from this, even assuming that you have someone who's an expert in antennas and RF systems, we're going to have to deal with fairly noisy signals. So what you want to do is to get 100% error-free communication, you want a robust way of representing information. And so I thought what I'd do is just discuss one way, okay? I'm not going to go into a lot of detail, but here's just one way of getting robust information. If you have some way of representing quadratic polynomials in two variables. When you think about the graphs of these polynomials, set them equal to 0, and you look at the resulting curves you get, what do you get? You get conic sections, okay? And what you can, and it's very simple, but see these quadratic equations are very robust. I mean, you can change the parameters in these things significantly, and they will stay an ellipse if they start out an ellipse, and they'll stay a hyperbola if they start out a hyperbola. So what you can do, this is just an idea that I'm throwing out. Okay, this is not something that I'm saying will necessarily work, but you need a robust way of representing information. So if you take conic sections and just as an example, allow ellipses to represent zeros and allow hyperbolas to represent ones. Well, if you play with these at all and you look at the kinds of rugged conditions you can subject these equations to and still get an ellipse when you start with an ellipse, and still get a damn hyperbola when you start with a hyperbola, you realize that there are very robust ways of getting 100% error-free communication. So although what Chris pointed out is true, what he pointed out is, see, the 100% error-free communication is like when we were working on the submarine robot, and you had to go through the validation gate. Well, the validation gate looks easy. And the thing is, it really isn't that easy to get through that validation gate. So what you have to do is not necessarily utilize any fancy stuff. Like once, I think it was the first time that Chris and the others got through the validation gate. So he was talking about this vehicle that utilizes laminar flow, but see, the fluid is nonlinear. I mean, we don't think of the nonlinearities for air because we're just small, and so we don't see the grand scale of the weather system and the climate system on Earth. But there are huge nonlinearities in that system. When you get a dense fluid like water, you have very strong nonlinearities. And once when that vehicle that worked with laminar flow, so it kind of flowed along water as if water represented a flat board. Well, I watched when Chris launched it once, and it started out in a flat trajectory, and then it just made small changes, right? Just very small changes, and the small changes were amplified. This is what happens in nonlinear systems, and that thing, he launched it. See, the validation gate was over here. And he launched the vehicle over here, and it just very small changes, and it went right through that validation gate. So what you're dealing with is not necessarily anything terribly technological. You want with 100% error-free communication. It's been known how to get this in conditions of noise since 1945 when Claude Shannon did his work. So this is not something new. But what you want a robust way, just like the clever way that Chris had with constructing this submarine. You want a clever way, a robust way that will represent data so that you can get error-free communication. So that's just what I wanted to talk about, that there are these ways of very simple ways, actually, of getting very robust representations for error-free communication.
So I have a question.
Yes?
So when you're saying error-free communication, you don't mean every transmission is error-free, because that's
No,
impossible.
no.
You mean retransmission,
No,
like
yeah,
IP.
What
There's no such thing as error-free
Which is what they're
transmission
asking
one direction.
What I mean is that you can make errors, but the mode of representation is so robust that the
So your error correction protocols, or-
communication comes out error-free.
So what they'll
But-
do is they have a block of data that they send, and they have you send it from your satellite. You do whatever you have to do on the satellite, you do whatever you have to do on your ground station, and you print out that data. And that data has to be error-free.
You're not
This is-
allowing retransmission, like in a protocol? Yeah, you must, you have to.
No, and you have 1 hour to, either half an hour or 1 hour to get your data, your printed data to NASA. They also have the right
Right,
to
but
listen in on your transmission, but you can't take your data, manipulate it, copy it.
No, I mean
Yeah.
just that the initial, every packet doesn't have to be error-free. If you get a
No,
packet,
no.
you detect an
No.
error, you
No.
can
Yes,
retransmit
yes,
through
yes,
protocol.
Yes, and
So,
that's the
okay.
idea that I'm talking about, having a very robust representation.
So just
so
using
you-
IP, something like IP protocol
Yes,
works for
exactly.
that,
So you can get substantial errors and still get error-free
But you remember you got low
communication.
power, you have very weak signal. You've got multiple ground stations that are tracking the data because you know it takes 2 of the 3 U.S. tracking stations, U.S. control tracking stations, to get that data. So you may get some data here and you got to get some data here, but it's got to come back and it's got to be whatever packet they send. I think it's 30-minute, 1 hour, and I forget I think it's 3-hour packets. And that data cannot be, it's got to be exactly what data they're asking.
You have robust protocols.
Very robust.
So,
From the moon.
so there's already existing like the CubeSat protocol right now, which the CubeSat uses. It's based on TCP/IP or IP as such. I'm not sure how error-free it is or how
Yeah,
what
and that's the
it
problem.
guarantees exactly.
Yeah, and
But
that's the
there's
problem.
already an existing.
And NASA's
layer on
pushing
top.
it to the next level,
Okay.
error-free.
Okay.
So you saw some images of the concept that I had for the Model A sub. This is what we built after all those things. This is still not what I saw in my head or see in my head because it has right angles. But we're getting closer and closer. And so this actually does not leak. It has an inner hole, an outer hole. All of our electronics go in here. This can be used in a surface water, underwater surface water and ground vehicle with this universal connector. Eventually, we want to be able to get in the air. And now that we've added the CubeSat, we want the control system to actually be the same control system that would run on CubeSat. So it's one control system, multiple platforms. And we've been working on this for a number of years. And the CubeSat is just the next iteration of what we're trying to do because right now in the military and everybody else has, the Army has a ground vehicle and has proprietary software. The Navy has an air vehicle, the Air Force has an air vehicle, and none of them can communicate with each other or interchange parts for any of those things. So they have something called the JAWS, Joint Architecture Unified System, where you can run it through iteration of a protocol so that these different systems can work. But I'm of the philosophy, why not start from the ground up and build a system that's dedicated to multiple platforms instead of try to retrofit something else that already does one thing, and now you want to do multiple things. We're starting out on the ground with a system that doesn't care if it's an underwater vehicle, surface water vehicle, or ground vehicle. It's a robust control system that is independent of the platform in which it runs. Any questions?
So you say we a lot, so what does that mean? Who's the
Pacific
we? Is
Nautilus.
it a,
Right now, it's the
is it
Pacific Nautilus. We've been in existence about 7 years. Dr. George sits on my board of advisors. I have about 3 other active board members and probably another 2 that are semi-active. They're retired.
Is it a for-profit company or a non-profit
No,
company
it's
or
nonprofit.
but a
It's an
company
organization.
corporation?
It's not a
Oh.
corporation. It's a nonprofit, not for-profit. Nonprofit is an official IRS designation. We don't get enough money to warrant an official IRS designation yet. This project may change that because we need about $100,000
I
to
was
build
going to say, how are you going to fund it?
So what we do is we've had very good success people in the robotics industry. And autonomous systems know our name. My people have been out in the industry, people who have gone through the project. Danny Boswell, the guy who designed that, I forgot to tell you this story. David Boswell came as a design guy. He wound up liking what we did. He went back to UCSD and got a degree in electrical engineering. Then upstairs at City College, got a degree, his A in electrical engineering, went to Berkeley, got his degree in electrical engineering, and then he's in a PhD program, and his PhD is robotics and art. So he took what we did here, and he's made a PhD out of it, and he's actually an artist in residence at SETI right now. We've got people that have gone from our organization to MIT, Cornell, Berkeley, myriad of other UCSD, State, and so we've got some people out there, and they got their start with us, and we teach them not to be students, but to be engineers. I have a couple of 13 and 14-year-olds. They're not kids, they're engineers until they prove otherwise. So we're engineers. We're expected to behave and act like an engineer, because that's what you want to be. If you want to be something, be it. If you don't, then don't. So we have some really good people that have gone through our program. Dr. George, Professor Worley, Dr. Bradbury have been very good at helping me structure a program that makes professionals. And this is the next iteration. So what I want to do, so my idea is a horizontal and vertical pipeline of students. So I want to do high school, community college, university, and professionals across multiple disciplines. And that's because the experience of the professionals, and I want to tie that with the ingenuity and the creativeness of students, and shake it up and see what happens. See what comes out. Yes?
You mentioned you've been planning this CubeSat thing for a while.
No.
Oh, okay.
4 weeks, maybe 5.
Okay.
A former member of our team sent me a Facebook message about 4 or 5 weeks ago with just a link. And that's how I got started with this. Dr. George mentioned in the class I was in. And so I've been doing this for 7 years based on Dr. George mentioning in the class and a friend of mine sending me a link. So about 4 or 5 weeks I've been working on this. New, but I've learned a lot.
Have you been working on it? Or do you know
No,
about it?
I've just been sort of reading on my idle time a bit about what this whole thing is about. I heard about it maybe a few months back, but just sort of reading, and then once I came across this, I was like, sure, I'll give it a time.
Yeah, come on board, drink the Kool-Aid. Any other questions? Yes.
Did you say drink the Kool-Aid?
Yes, I did.
Yeah.
I was referring to Dr. George. He was not interested in the project. And I said, come on, Dr. George, drink the Kool-Aid.
I am not drinking your Kool-Aid.
Too late, I think.
I think so too. But it's okay. Drink the Kool-Aid, Dr. George. It's just something funny I say. I don't know. I'm crazy. I told you I was crazy, right? I started out the presentation telling you I am crazy. I didn't lie. Any other questions?
So you said some of these components that are available. That you said some of them are flight rated.
Mm-hmm.
So does that mean that you don't have to do any of your thermal or shock or vibration analysis on your
Some
own?
of it, but when you put it together, yes, you'll have to do that again.
You will have to do
Yes.
that. So you have to figure out how to do the testing for
Yes,
that too.
and that's why Dr. Wayne is interesting, because he actually does this for SPAWAR, and he's going to try to see if we can get access to his environmental testing that he's done for his CubeSat. Again, there's some environmental testing that we can do based on this book, and so my idea is to do the stuff in this book, make sure it passes our thermal testing, and then possibly have to pay someone. But it's better, in my opinion, to have put it through our ability to test it and then pass that, and then have it go to something more rigorous. But yes, environmental testing is key.
Because NAVSEA also has some documents on different environmental testing.
I've been actually looking at solar radiation myself, actually. Hardening against solar radiation, there's a couple of methodologies. And one of the things that, I guess, they're a research organization, SPAWAR. So they've been doing research on CubeSats, what's available, latest and greatest, and some of the stuff that I presented to him was actually interesting, some of the stuff that he came up with, and he does that for a living. So that was exciting. That was exciting to me to sit in with him and tell me that he liked my approach, that I'm on the right track.
Yes, Dr.
And he
Wayne
has
had
a
been
PhD.
working on CubeSats for 3 years, so his group is quite knowledgeable, and he decided to mentor Chris and the group.
And I'm very happy about that.
Were you suggesting another place though that might be able they could do testing?
Well, I don't know if they can do testing, but there may be some people you may be able to reach out to up at NAVC Corona,
Okay.
which is up the road, and I mean those guys do a lot of quality assurance and performance assessment on like Standard Missile 3, missiles, but they don't really do the NASA stuff, but they do the missiles, which are made for something different. They're made for destruction.
Right, but you still have to make the
You still got to get.
shock,
You still
the
got to get.
pressure,
Yes, you
all
still got to
those
get
things
out of
that,
there. You got to get out of the
required
atmosphere.
on NASA. It's basically another rocket.
Yeah.
Just a bigger shock and vibration and pressure and some other things.
So I don't know which one would be more robust, if the SPAY or if the NAVC standards are the more robust. But.
It's an interesting. We can find out. Any other questions?
So NASA, I mean, when I was reading through it, they have some series of validations on Earth, basically, that we have to pass through, right? They have certain checkpoints.
Yes, it's called the ground competitions.
Okay.
They're basically design competitions. There are 4 of them. The only one you have to participate in is the number 4, because those who passed number 4 are the ones who are offered payload on the supplemental, the SLS.
Okay.
But my philosophy is the more of these you do, the more feedback you get from NASA. Right. And then coming up in about 120 days. I'm not sure if we're going to be ready. Dr. Wayne was concerned about our timetable, but I told him we don't set the timetable, NASA did.
So do we know what those ground series of validations are?
There is a checklist.
Okay.
I haven't got to a checklist yet. I've read through the entire document that NASA put out. It's like 30 pages. And then I broke it up into 5 sections, and each one of our 5 of our members are becoming experts on those sections. And one of those sessions includes the documents they're talking about. And so I actually broke his section in half again, because he said it was a lot. So he's actually focusing on those documents. And if he needs help, I'm going to assign people to him, because I read the document and I know pretty much the document in my head. But it'd be nice to have somebody who's an expert on that section of the document, and I can't be that too. Any other questions? So if you're interested, and we are very much looking for people to be interested, you can sign up on our website, pacificnautilus.org/get-involved.
So it's a full-time, or
It's not full-time. We work on it when we can. I'm assuming most people have full-time jobs. And my other philosophy is that if you got one person working 20 hours a week or 10 person working 2 hours a week, we get the same amount of work done. And so we go on the 10 people, 2 hours a week, 20 people, 2 hours a week, whatever it takes, depending on the size of the organization. And then we are very effective when we break up the tasks into small chunks that people can manage.
Do you have lab space to work in, that
No.
kind of thing? Or that's just...
No. We do what we have to do. Right, Dr. George?
Well, I have lab space, but it's something where people haven't really made use of it in your group.
Right. We used to work with another nonprofit where we had 24-hour access to a complete section of his thing, but they went under, and so we lost our lab space. It was actually nice. The only problem was it was a building, a room. We had about a section as big as this, but there was no windows, so it'd be 1 o'clock in the morning before we realized we'd been working for 6 hours. But it's kind of cool to be able to have that kind of space to be able to do the things that you need to do, and we actually did some pretty cool work. This performs like a dream, and it's not even where I want it to be. This gets in, it'll go through validation.
This is really kind of wonderful work for the community college students and the high school students. I think that just working with something like this and trying to say make these submarines waterproof is a real
Challenge.
lesson.
We got, like I said, there are teams that are still leaking. We have never leaked. There are 34 screws in this. I didn't realize that. So one of my project managers went to buy them, and he says, "Chris, did you know there are 34 screws?" And I go, "No, let me count them." So you have a gasket, an acrylic plate, another gasket, and an aluminum plate. In the event of a catastrophic failure of the outer hull, the inner hull will not breach. I don't think we've ever got a drop of water in this vehicle, ever.
Where were the parts machine? It looks like the acrylic and stuff. Where did you?
So
laser
we
cut?
had the acrylic hull built by Red Out Plastics, which is now E-Plastics. They did a terrible job.
They always do. They always do.
Well, unfortunately, the stuff in their showroom looks much better than the stuff that they actually. One of the things they did was the acrylic plate didn't match the holes, so we spent recreating our acrylic plate. And I don't know why they did this. This was very disappointing. But these should be attached to not only to the bottom, but to the side, but they're only attached on the bottom. So if you screw these out too hard, they'll pop off. They should be attached, and they were told to attach them both to the side and at the bottom. And actually, it's not a glue, it's a bonding agent. So it actually melts and bonds them together. But they can only take so much pressure if they're only bonded on the bottom. They did not bond them to the side of the hull, which is what we asked repeatedly.
So how do you hold your meetings? Do you Skype?
Hang
out?
We
What?
meet Saturdays at, we used to meet in Claremont at NG until they closed, and now we meet on Saturdays at the living room. Lestat, sorry. Lestat, sorry.
So it's a face-to-face?
Yes, on Saturday mornings. And then those who would want to participate that aren't able, we would do a Skype, or we have like a whiteboard that we're trying to set up where people can do their work. And Base Camp, you ever heard of it? Yeah, we have a Base Camp where you could be in your timelines and your deliverables, and when you submit something, it gets sent out to the whole group. So we have that. We try to be as professional as possible.
Well, it's if you're all volunteer base with everybody's different schedules, trying to dovetail that stuff to be productive
Like students?
is a challenge.
Yeah, like getting students to be able to do it with different schedules. Yeah, I've gotten good at this. 7 years of doing it. So we have some of the tools. Again, this will be the biggest project I've ever managed. Way bigger than anything. I mean, I worked for a company that did $1 billion a year, and I ran their accounting software, and I had 80 accountants on the 9th floor and 5 separate satellite locations, and this is way harder. Some of my gray hairs is having 80 accountants upstairs on the 9th floor twiddling their thumb when the software went down. At a minimum of $80,000 each. So this is way harder, but I like these kind of challenges, which is why it's too hard. I don't like it. It's not hard while you're doing it.
Is there some secret to getting people to work for you to do what you actually want them to do?
Charm.
Charm?
You think we've probably had 100 people to this group, and we don't pay any of them, and we've made some great work. When we did this, in order to fix that, we were up for 24 hours.
For example, for the submarine project, some of the students had their sights set on, say, like going to MIT or something.
Or Berkeley.
And so there was a certain level of motivation for students to work on the project and accomplish things.
But these are accomplished people. Getting them to work on this project as opposed to another project is the skill part. Because Danny could have done any project he wanted to. He really could have. He was actually a very bright person.
He was very dedicated.
Jim Cady, the first guy who worked on this with Dr. George and I, he's the ones who drew all those drawings, getting him to work on this project.
he was the one who actually introduced me to the project, and then
Then he mentioned it in class.
and then he disappeared after.
He got a job.
He got a job.
He got a job. I
don't
gave him a
know.
recommendation. I've given lots of recommendations. Lots of people got recommendations. They got internships. One guy, Dana Long, worked on our project. He did the poster presentation with City College in their program, and he wanted to apply to a summer internship. Was paying $5,000, so I did a recommendation for him, and he called me the second day and said, "Chris, this guy didn't know what he's doing. He didn't write reports. He didn't put down his notes. He didn't do anything you showed us how to do." So it was cool that he learned something, and then he went up there and fixed someone else's project, because they just throw a autonomous system at you and say, "See what you can do." Well, we do reports. We call it a WAR report, or a weekly activity report. We do them every week. And they submit them on Thursdays to the project manager, and he submits them to me on Fridays. And even if you say, as a student, had a test, didn't do anything, you submit your report.
So what's the current size of your CubeSat team, per se?
10? Dr. George?
What?
About 10 people?
Yeah, we have about 10 people.
I have about 7 community college students, 3, make that 4 13-year-olds whose grandfather bugged me to work with them, and I finally relented. And they're working on a CubeSat project. So they're 12 and 13, and they do Arduino programming, and they're learning everything, including how to be professionals. One of the things I did when the new group came on board is I had one of them, Dion, explain to them some of the stuff. And last week we had a programming assignment, and there were some people on the small team that was unable to understand what was going on. And he was sitting in the back telling him, I said, "Excuse me, you have a voice, use it. Walk up to the front of the group, say, this is what the problem is, and then tell him how to fix it." And he did that, even though he's only 13 years old. So, and then they got it working. Because he knew how to do it, but he wasn't. I try to teach them to have a voice. You're not going to go to work for a company and you say, "I want that $10 million project, but I want you to give it to me because you think I'm pretty." You're going to have to convince someone that you are the right person for the job. And that's what we teach them. Everybody does a presentation.
There's Maker Fair next week up in Orange County. If you guys are free. Other than that, see you next week.
Thanks, Hansel.
Beautiful. It's pretty good.